Gabby with Forney Industries, and we are going to go over the Forney 220 AC/DC. TIG welding is a more advanced welding process. So there is just a couple different things that you have to keep in mind when you are TIG welding. People refer to it as a couple different things. So first is TIG. TIG stands for Tungsten Inert Gas. And then you have GTAW, which is Gas Tungsten Arc Welding. And then also some people refer to it as Heliarc. That's what it used to be called, and it has evolved into TIG welding. So TIG welding is done with a tungsten electrode. That electrode does not melt or enter your weld pool. So it will be inside of your torch, and that is what your arc is going to come off of. To allow a extra material to go into your weld, you're going to hand feed that material with a filler rod, which is just a piece of rod. You could use MIG wire for this. Some brazing rods can also be used with TIG welding. So that is how we are going to be actually doing the process. So that's why it becomes a little more advanced, because instead of using one hand, you're going to end up using both hands and your foot as well if you're using a foot pedal. Or the other option to TIG welding, if you don't want to use a foot pedal, you could also use an amperage torch. So an amperage torch allows you to control your amperage at your finger on the torch itself. So instead of using a foot pedal, you can use that hand control. So we do offer this machine, the 220 AC/DC, with the addition of a foot pedal or the addition of a amperage torch. So that is up to you when purchasing this item, which kit you are going to buy. So now that you understand what TIG welding is, we're going to go through this machine and we're going to go through all the settings, the lights, and just kind of get a better understanding of what everything on this machine means and what it's going to change and how it's going to help your weld. So first we're going to talk about the knobs on this unit. So each one of these knobs are infinite, so they will continue to spin, which is a nice feature. Also, both of these knobs click. So if you press on this, both of them click. The side over here where you are controlling your amperage, this click does nothing. So don't worry if that's not changing anything, it's not supposed to. This click over here is going to filter through your menu that is going to allow you to adjust a couple extra settings as to whatever you have your amperage set to, and we'll talk about that in a second as well. Then we have a process selector. So our process selector here in the middle is going to filter us through AC TIG, DC TIG HF, HF stands for high frequency, DC TIG lift, and DC stick. So this machine is primarily used for a TIG welder, but it can also be used as a stick welder. Now we're going to go over the UI lights here up top. This far one closest to your amperage has a little thermostat underneath it. That is going to tell you when your machine is overheating. So if your machine overheats or hits duty cycle, that light is going to turn on and become illuminated, and it's going to say, hey, something's wrong. You might also get a fault code here on your front screen, and all those fault codes will be available in your manual, so you can check those off of there. Our next UI light is going to be our voltage in, so that is a circle with an arrow and a V. So we have this machine plugged into 240 volts. That is why we have a green indicator. So when you're plugged into 240 volts, this machine is going to display a green light right here on our input voltage. If this light is white, that means you have it plugged into a 120 volt outlet. If this light is flashing or doing anything other than those two things that I mentioned, then something may be wrong with your input power and the machine's trying to tell you, hey, we don't have clean power, so we're not going to work. Our next light here is a circle with an arrow out. This one's a little confusing to some people because they think it is a fault code or a fault light. It is not. It is actually a VRD, so it is a safety feature. So that is just saying that we have our VRD and it is on because we are not welding. When we go to weld, that light will turn off, our VRD will turn off, and then once the weld is done, it will come back on and our VRD protection will be back on. So just keep that in mind if you're looking at your machine and you see that light illuminated. It is not a fault, it's just illuminated because of the VRD and it's on, it's just telling you that it is on. So now that we've gone through that, we will talk about each process of TIG welding and what you're going to need. So for the overall process of TIG welding, you are going to need an inert gas. So like I was talking about earlier, the TIG, tungsten inert gas. So we need our inert gas, which is going to be 100% argon. In most cases, people are going to be using 100% argon. There is a couple other options of a helium mix and such, but argon is the most commonly used gas for TIG welding. And then, like I mentioned before, we're plugged into 240. We're going to have the full range of our amperage selection as well as our balance and frequency and pulse. Once we take this machine down to 120 volts, we actually lose half the range on there because we're only getting half the power. So if you plug your machine in and you're seeing it's not going all the way and then you realize you're in 120 volts, that is correct because we cannot go as high. So just keep that in mind as well. Alright, so AC TIG welding. When you are AC TIG welding, you are going to use a tungsten electrode. A lot of times people use PIR or have used PIR in the past. This machine with the inverter technology that it has, it is not going to work with PIR. PIR will make that, basically the tungsten will just melt and it will consume itself, so it'll kind of just melt into a ball and continue to ball up. And that is just because this machine is not made to work with pure tungsten. So if that is something you are used to using, I'm sorry, but you might want to look into like a lanthanated tungsten or a serrated tungsten just to get a little bit better performance. If you try to use that pure, you're just going to have really bad results and then you're just gonna, it gets frustrating. So a lot of times that we see when somebody's using pure, that's what the problem is, and then they change over to a lanthanated or a serrated and then it welds perfectly fine. So also we have our connectors here. So in some cases, machines will auto-select. Our machine, you just have to put it into the correct places. We do not have an auto-detect. So when you are TIG welding with this unit, your electrode is going to be into the negative and your ground is going to be in the positive. So TIG torch in the negative and your ground clamp in the positive. So that is the case whenever you're TIG welding, no matter what setting you're on, you want it to be set up electrode negative. And then with stick welding, you can swap that out, of course, but any TIG function, you're going to have an electrode negative. If you have an electrode positive, you're going to see the tungsten get damaged. You're going to see a weird arc coming off of it. So just remember electrode negative. All right, so now we're going to go through our selector on the side of our AC TIG settings. So our first setting is going to be AC frequency. So what frequency does in a weld, it's only available on AC. So when you increase your frequency, it's going to narrow the shape of the cone that your arc is making. When you increase that, then that is going to make your cone a little bit softer and your arc a little softer. So with an increased frequency, it's going to allow the cone to be a little sharper. It's going to allow stabilization to the arc and reduce arc wander. So that can come in handy when you're doing a small weld. On our frequency, we do have a range from 40 all the way to 120. A lot of times we will run it right around 60 hertz because that's what we have coming in from the wall, so it just balances everything out. Okay. And then the next setting we have here is AC balance. Our AC balance is going to control, it adjusts the negative and positive current within the alternating current. So within your AC, it's going to alternate or help control how much those alternate between one another. So more negative, so this is a balance percent electrode negative. So with more negative, that gives you more penetration, so more penetration in your weld, and more of a positive, so that would be on the lower end of this, then you are going to get more cleaning action, and when you get the cleaning action, your arc is actually going to make your tungsten ball. So you will start to see a small ball at the end of your tungsten. That is totally okay. Another misconception in AC TIG welding with new inverter style technology machines is that you have to ball the end of your tip. You do not have to ball the end of your tungsten, so you can just sharpen it just like you would in any other process in DC, and you just sharpen it like a pencil essentially, and then give it a little bit of a landing, and that's perfect to use with AC. You do not have to ball that at all. Okay, so the range on our AC balance is going to be from 50 to 90. Okay, our next setting is pulse. So like I mentioned before, those first two settings, frequency and balance, you only have the ability to change that on AC TIG. But when you get to pulse, you are able to use that in AC and DC TIG. When using the pulse setting, it is going to allow you to help reduce the total heat input into the base material, as well as help with out of position welding. So when you're using this pulse function on this machine, your high end is 30 pulses per second, which will be almost unnoticeable. So you won't really be able to tell that that's actually happening, and that it'll be happening so fast that you won't even know. And then our low end is going to be a 0.1. So you're going to be able to see that because it's going to be very drastic. It's going to be an off and on and off and on, and it's going to take a little longer for that process to happen. So you're going to notice it a lot more than you would once you get into like the 20 pulses per second. So just keep that in mind, depending on what setting you're using in that range. Our next option that we have to change is going to be our percentage on. So that's going to be how long, what percentage is the high current or the peak current going to be on compared to the negative. So that range goes all the way from 25% all the way to 75%. So you can do a quarter of that range, or you can do 3/4 of that range. So that's just going to determine within that second how long it's staying on your high current and how long it's staying on your low current. All right. So now we're going to go to DC TIG high frequency. So I should mention AC is high frequency all the time. You do not lift arc on an AC frequency, only because as soon as you touch that as soon as you touch that tungsten to your base material, you're contaminating it. So because aluminum is so important to keep clean and make sure you're not contaminating it, it's very important that you do not touch your tungsten to it, and that you make sure you do the proper cleaning and everything like that we'll talk about in a little bit. So DC TIG HF, once again, it's high frequency, so you're going to be able to use your pedal. You're not going to have to touch your metal with it, anything like that. On your amperage, we have 5 to 200. This amperage range is the same through AC to DC lit. Okay. Our selectors here, we're only going to be able to control our pulse and our pulse percent on. That is the only thing that's being controlled separate from your amperage on your DC side. If you are a beginner to TIG welding, I would recommend starting with your pulse off. Pulse on is going to reduce your heat, so it's going to make it a little more difficult to weld. Also, if you aren't familiar with pulse, it might be a little confusing on how to actually weld with it. So as a beginner, I always just recommend that you start with pulse off and just give it a run with just amperage, and once you get comfortable with that, then you can go ahead and you can add pulse. So DC lift TIG, once again, this is lifting. So you are going to touch the base material with your tungsten and you're going to pull off. This can be used if there's, say, you're welding on a car and there's a computer system in it, and you don't want to fry the computer system. So you can use lift TIG instead of high frequency TIG, and then you get rid of that concern completely. So just a couple things that high frequency does, because it's going to jump all the way from your ground to your tungsten electrode that's inside of your torch, it's got to travel through a lot. So if it finds a quicker ground or if it finds an electronic component, it is potential that it can fry that. So keep that in mind when you're welding on a car or the next project you're doing, that it could ruin your computer system. Your amperage control on AC TIG is going to be from 10 amps all the way to 200 amps. On DC TIG high frequency, we're going to be at 5 amps to 200 amps. That is the same on DC lift TIG as well. And then on DC stick, we're going to go from 10 amps to 170 amps. So with TIG being a more advanced process, it also comes down to a couple other things that are very important to keep in mind. One being material prep. So when you are prepping your base material, you want to make sure it's very clean. If it's not very clean, you're going to trap impurities, and you can just create a very poor weld, which can cause to cracking, or it can cause the weld to break or to not even hold, or it may not even weld. So one thing to keep in mind is when you are welding aluminum, you do not want to clean that material with anything that has steel in it. If you clean that material with anything with steel in it, it is going to impregnate the steel into the aluminum. And once that has happened, you cannot get that aluminum clean again, and you're going to have to figure something else out for your material that you're going to use. If you try to weld on aluminum that is impregnated with steel, it is actually going to be very dirty. It's going to be black and sooty. It's going to be sparking. Anytime in TIG welding that you see sparks, that is bad news. You don't see sparks in TIG welding. TIG welding is a very clean process, no sparks, small arc. So if you see any kind of sparking or dirty or anything like that, something is happening that should not be happening. Another very important thing to remember is setting up your torch. So when you go to weld, you want to make sure that when you put your torch together, all of your consumables are going in the correct way. So when you're assembling your torch, or if you are coming to your machine for the first time to use it, you want to make sure just to disassemble all the components on your torch. And then you will reassemble in the order of putting in your collet first, your collet body. You will then screw on the cup. Once you have screwed the collet body into your torch head, you will then screw the cup onto the collet body. Then you will put the collet in the back end of the collet body and screw your gas cap onto the back of the torch. Just loose enough to where you can still feed your tungsten in through the front. If your collet body is loose inside of your torch, that is allowing your high frequency to bounce off of those threads because it's finding the first space that it can jump. It's going to allow it to jump off of those threads instead of jumping off of into the tungsten. What that can lead to is that can lead to arc wander, it can lead to poor welds, and it can lead to frustration. That is one thing that you can try to trace down, and it becomes very difficult because you don't ever think about your consumables, right? So you always want to make sure that when you unscrew your cup on your torch after using it or before using it, that your collet body does not unscrew with it, because if it does, then you need to reassemble your consumables so that that cup is not one unit with the collet body. Those need to be two separate pieces, and they need to be screwed in on two separate pieces. When using this machine, we do recommend a 3/32 tungsten. So that way it can handle the amperage that we're putting out, but also be good for all around thicknesses of material. If you wanted to use a 1/16, or if you wanted to use an 1/8, that is totally fine. We are just going to limit what you will be able to do with the TIG welding, unless you switch out your tungsten when moving to different size materials. It is also very important when you're TIG welding to sharpen your tungsten. So if you get any kind of contamination on your tungsten, you just want to make sure that you're sharpening it and cleaning that off of there before you make your next weld, because it can affect your next weld. Also, when sharpening your tungsten, you always want to put a landing on it. If you do not put a landing and you leave a sharp tip on there, the tungsten's actually going to heat up, and because of the material is so thin where that tip is, it's going to melt into your base material, and tungsten will actually create an impurity. So that can cause problems in the final result of your weld if you are to just over sharpen your tungsten and weld with it and allow that to melt into your material. So that's why we always just put a small landing at the end of your tungsten and call it good. The steeper of an angle that you have, the less penetration you're going to get. The more blunt that your end is, the more penetration you will get. When using filler material, you will have the options of using a 16th or a 3/32 or an 1/8, kind of just like your tungsten electrodes. But you want to base your filler metal off of your thickness of material and your settings. So a lot of these things that are very important when it comes to TIG welding are really based off of your application and what you're using. And if you cannot come up with a good setting, or if you can't determine what you're going to do, always feel free to reach out to our tech department. They are more than happy to help you with that. But we're going to try to get you some information from this video to help you out. So speaking of tungsten, there's different types of tungsten. The ones I'm going to mention, I'm just going to mention the 3 most common. So we have a seriated tungsten, which is a good all-around tungsten, so you can use it for steel or aluminum or whatever material you're welding. It's good with high heat, and as well as holding its point when that heat is introduced. You have lanthanated. Lanthanated is good for AC welding. If you have a balled tungsten, it will hold a ball better than other tungstens, but as I mentioned before, you don't have to have a ball on there, so that one is good for just higher heats, which can be shown in AC welding. So AC welding can get a little hotter, and that tungsten is better for that material. It's not going to get brittle or anything like that. Then you have thoriated. Thoriated is going to be another good all-around, so it's kind of just like a next step up from a seriated. And a lot of times when people are TIG welders, they are married to a tungsten, so say. So whatever tungsten that you are most comfortable using, go ahead and use that as long as it's not pure. If it's pure tungsten, I'm sorry, but we are going to have to find a different tungsten that you'll like a little better. And if you are in that situation, I would recommend trying a seriated first or lanthanated, whichever you would like to. So TIG welding is also another kind of picky process, you could say, because you do have to do this indoors. So if you are welding outside and there's any slight breeze or anything that's going to come into contact with your gas that's coming out of your torch and going to allow that to blow away, that will cause your material not to get gas coverage. So if you're trying to weld outside, just make sure that you can kind of control that environment and that you're not going to run into issues where the wind comes up and blows away the gas from your weld. Another good thing to keep in mind is that if you're welding right next to this machine, if you have your plate on a piece of metal or table or whatever next to your machine, if you are welding here and you see impurities, it is more than likely because the fans on the back of this machine are so powerful that it's going to be pushing air out of these louvers, which will cause the gas to be blown away from your torch. So make sure that if you're seeing impurities or it's looking like you're not getting gas coverage, 1, your bottle's full and you actually have gas. You're set between 15 and 20 CFH on your flow meter, and that you have no external air blowing to allow that gas to be blown away. So that is our overview on the Forney 220 AC/DC. If you have any further questions, you can always reach out to our Forney expert techs. You can also get more information about our welders and products at forneyind.com.